Okay, welcome back. So hopefully you finish up this table. You can start to see a pattern kind of developing here. So as we change the number of increases, our price keeps going up by $2 every single time. Our number of shirts sold goes down by 3 every single time. And you'll see that so far revenue keeps going up. But you'll notice here that it's going up by less and less every single time. So there is going to reach a point where, again, there's going to be some sort of maximum revenue that she can make, but then the price is going to get so high, not enough people will be buying them, so she'll start not making as much money. So that's really what we're trying to get at, is trying to figure out how she can get the most money possible. But before we get to that point, we want, again, we don't want to be able to have to do this using a table every single time. It can take a long time, and it's not necessarily most effective because, what if it's possible that instead of increasing a price by $2 every time, it actually winds up being not a whole price increase that gives you the maximum. That'll be harder to see from a table. So we need to have a more algebraic way of doing this instead of just guessing and checking using a table. So following this pattern here, if we let our number of price changes be x, you'll see here that every single time our price starts at $10, then goes up by $2 for every price change. So in general, our price is going to be 10 plus 2x. Okay, $10 plus $2 for every price change. Okay, for our number of shirts sold, we start at 45 shirts sold, and we lose 3 for every price change. So we lose 3 for every x. So our number of shirts sold is going to be 45 minus 3x. Okay. Well, and then how do we find the revenue? Well, revenue is just price times number sold. So we get 10 plus 2x times 45 minus 3x. Okay, so what we have right here now is a revenue equation. And hopefully it looks a little bit to you like factored form, because that's what it is. It's the factored form of quadratic here at this point. Let's see what this looks like on a graph. Okay, so on a graph you can kind of see the relationship's quadratic. So again, x here's the number of price changes. R is on the vertical axis here. So as the number of price changes goes up, you can see the revenue going up till it reaches a maximum value. You can see where it is from there, and we'll go through calculating it later. And then we can see it come back down to the point where, again, the revenue is going to be 0. So the relationship is quadratic. We can find a lot of information from a quadratic equation, and that's all we need to do to solve this. So once we have this equation, okay, now, again, to summarize here, if we let x be the number of price changes, and revenue is price times number sold, we get 10 plus 2x, 45 minus 3x. So to find the number of price changes that will maximize the revenue, well, okay, so we want to try and find the number of price changes. That's our x value. Okay, we want to find the maximum value. Okay, so we want to find the x that will maximize the revenue. Well, the x value that gives you the maximum is really just a way of asking for the axis symmetry. So to find the axis symmetry, what do we need? Well, let's take a look at what we have for an equation first. Okay, so if you look up here, we have factored form. So from factored form, we can find the zeros by saying each of these factors equal to 0. So we get 10 plus 2x. We set that equal to 0, solve for x. Okay, and we get 45 minus 3x for other factor. Again, set that equal to 0, solve for x. Okay, you go through the algebra here, you're going to get x equals negative 5. And here you're going to get x equals 15. Okay, so what this means, if you change the price 15 times, so if you increase the price 15 times, or if you increase the price negative 5 times, now what do you think it means to increase the price a negative number of times? Well, a negative increase would be a decrease. So if she has a negative 5 price increase, that actually means she's decreasing the price 5 times. But in any case, at these two numbers of price changes, we actually wind up getting no revenue. And then again, we can see that from our graph here. When x equals negative 5 and x equals 15, we have our zeros. So we're looking for the axis symmetry. It's halfway in between these two x-intercepts. We can see it on the graph to be 5. We need to be able to calculate it. So going back here, remember to find your axis. It's halfway between your zeros. So you have negative 5 plus 15 all over 2. So that gives you 10 over 2, which gives us a value of 5. So that right there tells us that if we change the price 5 times, we get the maximum revenue. Okay, so think about what 5 price changes means for her. So if she's going to change the price 5 times, what's the selling price going to be? Well, her price was, remember, $10 plus $2 for every price change. So if we put in the 5 price changes in here, well, that's going to give us 10 plus 2 times 5. So it means that t-shirts are now going to be $20. Okay, so This is what we call her optimum pricing strategy. She will choose this price, even though it's not necessarily best for the consumer, it will maximize the revenue coming for her, and that's all she cares about. So she sells the t-shirts for $20. How many t-shirts will she sell? Well, remember their shirts were 45. She started off with 45 sales, lost 3 t-shirts for every price increase. So again, putting in our x equals 5 into here for x. So 45 minus 3 times 5 is 45 minus 15. So she'll sell 30 t-shirts. Okay, so she will sell 30 t-shirts at $20. Her revenue, which is price times number sold. Well, looking at our equation here, we put in the x here into this bracket. X equals 5, we got $20 here. That was in part E. We put in the $5 into here, we got 30 shirts here. So 30 times 20 should give us a revenue of $600. Okay, so all told, from that t-shirt, the maximum revenue she can make is $600. So again, once you had the equation set up, you weren't being asked to do anything new. It was just a matter of finding different pieces of the parabola, whether it be the x-intercepts, the x-center, the optimal value, whatever. So again, that's all things you can do. Once you have the equation set up, it's just a matter of figuring out what the equation is asking and then going through and solving. So your homework's there. This is actually the end of the first quadratics unit, so that's 1 down and 3 more quadratics units to go. Once we finish with this unit, we'll get into something else. All right, cheers.